Let's have a run through the notes that I passed out for the sedimentary rock chapter. It starts out here talking about how sediment actually turns into sedimentary rock. We talked first about weathering. That's how rock breaks down into sediment in the first place. With granite, it will turn into like clay minerals and quartz grains and ions dissolved in water. But when that sediment gets deposited somewhere, there's two ways that it will turn into sedimentary rock. One way is compaction, and that is when the extreme weight on top of all of the sediment will just compress it down into sedimentary rock. And that happens with things like mud. I'll go for the yellow here. Happens with things like mud. Then there's another process called cementation, where pebbles and sand they can't be compressed; they're too hard. But water can percolate down through the spaces of them and leave minerals behind and cement them all together. So that's what happens with sands and pebbles. The sedimentary rocks are divided into two types. We have our clastic, and this is mud, sand, pebbles, stones, all of this stuff will turn into something called clastic sedimentary rocks. The disc in the book calls it detrital, but it's the same thing. The shales are what happens when you have mud that turns into sedimentary rock. The sandstones obviously are sand grains that have been cemented together. They're mostly quartz. And the conglomerate is where you have pebbles and sand. It kind of looks like concrete. They're all cemented together. And then if the pieces are angular, it will be called breccia. That's the difference between them. Then the other category is the chemical sedimentary rocks. So this is where you have ions that come out of solution and eventually get deposited somewhere. And the most common type of chemical sedimentary rock are the limestones, and they have various varieties. You only get proper limestone in tropical seas, like down around the Caribbean. That's where you see a lot of white mud, and you don't see that around Newfoundland. You see that down around the Caribbean, where the water is nice and warm, and calcium carbonate is able to accumulate in the seabed. If it's only partially lithified, it's still soft. It's called chalk. And if you look at chalk under a microscope, you see the shells of microscopic organisms that are made of calcium carbonate. And if that chalk then gets compacted into a hard rock, it's called limestone. But chalk is the kind of like the intermediate form between just like a white calcium carbonate mud and a hard limestone. You can also have coral reefs, which are also biochemical. They're the precipitated, shells of these small creatures. And then the coquina you've seen in class. This is the seashells that are all smashed up and they get squished together and cemented together. Travertine is what it's called when calcium carbonate is deposited in caves. And that comes in, like it could be just like the cave walls. It's a lot harder than ordinary limestone. We have these features on the roof called stalactites and features on the floor called stalagmites. But all of the travertine itself, it's inorganic. It's the one form of limestone that doesn't have any organic origin. It's called travertine. There are also cherts. Now, those are made of silica, which is what quartz is made of. There are plankton in the ocean. These are single-celled algae that have silica shells, and when they build up on in the seafloor sediment, they will eventually get turned into a form of chert. Flint is the most common example, and you've seen this in class. It's very similar to obsidian. We also have evaporites, and that happens when you have bodies of water, like it could be lakes or seas or whatever, that evaporate and they leave behind deposits. This can happen with gypsum, right? Like that calcium sulfate will come out of the water as it evaporates. But most common is rock salt. And so you have things like salt flats, right? And you saw the video in class where like where temporary lakes in the desert um, that have dissolved salts out of the mountains. All of that rainwater will wash down into the sea, or sorry, into the valley, and then evaporate and leave salt behind. The Dead Sea in the Middle East is another example of an evaporate deposit. We also have coal, which is a biochemical sedimentary rock, and that originates in swamps and bogs where oxygen levels are low, which means that decomposition doesn't work very well. And where decomposition doesn't work, all of this organic material will end up building up. It will eventually turn into a peat, which almost looks like ground up wood chips, soft and brown. When that is buried more deeply and compacted, it will turn into a brown coal called lignite. And when it is completely transformed into pure carbon, it's called bituminous coal. And if it ends up getting metamorphosed, it will turn into something called anthracite, which is very glassy looking, almost looks like obsidian, but it's pure carbon. And then we went through a bunch of these features here, but I have another form that I'm going to go through that has pictures of all of these. And so I'm going to end this little presentation now and then move to the second one.